Today I'm going to be presenting Rutherford's model of the atom and Bohr's model of the atom. Rutherford versus Bohr, two key atom models, by Pezzarello. So first of all, I'm going to give you some context. Atomic physics dates back as early as the 6th century. It was first developed, really developed in the 18th century by John Dalton, and he laid out chemical elements. They were first kind of laid out, understood, broken down, and then John Newlands invented the periodic table, which you can see here. This is the first iteration of the table. And then it was Dmitri Mendeleev who later on created the framework for the modern periodic table, because the first one that was invented did not have any room for anything to be added. It was just elements. And then Dmitri Mendeleev came in and added on more. And of course, that's the basis of all elements, is the periodic table. And scientists have used various models to show off these elements and their protons, neutrons, and electrons. So the periodic table was last updated in 2016. That's the one we know today. And of course, some context, Gilbert Lewis created the Lewis dot structure, also known as the cubical atom, in 1902. And then J.J. Thomson had the plum pudding model. I always remember that because of its funny name. And then, of course, finally we had the Bohr model and the Rutherford model were created separately, and then they were coupled together. So you can see right here, we got some pictures. First model, we got a little phosphorus. That's the cubical atom. And then this is the Rutherford diagram. All right, so we got a problem. Molecular models allow scientists to visualize elements. Molecular models are essential to atomic physics, and molecular models throughout history have modeled atomic structure in varying ways. So in late 1911, Niels Bohr introduced the Bohr model, of course, is right up here first, and it was directly made to target the shortcomings of the Rutherford model created by Ernest Rutherford. You can see that one down here. See, it's just a proton, and then it's a bunch of scattered electrons. But this one is designed to show the electrical energy that comes off of it. You see it's kind of a more stable with the electron rings, and you can see energy radiating off of it. And then, of course, this one is just literally a bunch of electrons that have been thrown into a cluster. So Bohr's quantized shell model shows the electrons in a stable orbit, and it didn't work well for atoms with more than one electron. But Max Planck had determined energies of photons that were not equally shown. So that's shown better in Bohr's model. But then, of course, there's no concept of any stable molecules in Rutherford's model. So the Rutherford-Bohr model bridged the two together. So in 1913, the historic Rutherford-Bohr model was born. And you can see here, you got your protons, your neutrons. Then, of course, you have all your valence shells, and 2, 8, 8, and then 18 if you keep going. And you got your nucleus. And, of course, I just added here at the bottom, there's a formula. Technically, there's a formula. L equals NH over 2 pi, L meaning angular momentum, and N is the principal quantum number, and H is your Planck's constant. That's to do with in quantum mechanics, you calculate the energy released by certain elements. And the explanation and implication. So essentially, Rutherford understood that electrons were outside the nucleus, the electrons were equal to the positivity of the nucleus, and electrons were scattered outside the nucleus. But his unstable diagram only provided a number of electrons. It's just, we got a bunch of electrons going on, nothing's organized, it's all out there. And of course, versus your Bohr atom, you can see you have your positive in the middle, valence electron, you can see the energy, you can see the electrons, how they're organized, how they're stable. So Bohr's quantized shell model shows how the electrons can have stable orbits. The order of the maximum number of electron orbits in the Bohr-Rutherford diagram are 2, 8, 8, 18, as I said before. And it was initially Bohr who actually approached Rutherford. He was looking for a joint partnership to bring the two flawed systems, just to bring them together. And they teamed up for that Rutherford-Bohr diagram, which is often referred to as the Bohr-Rutherford diagram. Doesn't really matter how you refer to it. And it was used in quantum mechanics for identifying energy levels, as I said before. And there were some inaccuracies, but it's a great introduction to quantum mechanics due to the energy levels that you can measure. So, how to draw your own Rutherford Bohr diagram. So basically this is a element of chlorine, but it can be anything on the periodic table. So say for example, we're going to go for chlorine. We know that our atomic number is 17, and our element number is 17, and our atomic number is 35. So 17, that's the number of the element, is, of course, we have 17 protons. You put that in the middle, you just draw 1, 7, P plus, and then you have your neutrons. So you basically take your atomic number, subtract this, 35 minus 17 equals 18, boom, there we go, we got 18 neutrons. And then, as I said before, the number of positive charges equals the number of electrons. So protons equals number of electrons. So if we have 17 and 17, we have 2 in the first ring, 8 in the second ring, so 2, 4, 6, 8, we should have 10. And then to get the last 7, we have 2, 4, 6, 7, so 10 plus 7, 17. And that's how you draw your own Rutherford Bohr diagram. Now, to conclude, basically in summary, Bohr and Rutherford each created flawed diagrams. Rutherford showed electrons, but they were not in stable orbit. So Bohr created a model for stable orbits and quantifiable energy levels. Bohr approached Rutherford requesting the partnership, and of course the Rutherford-Bohr diagram, sometimes known as the Bohr-Rutherford diagram, was jointly created between the two of them, and it was in 1913 that was released. And it is quite simple to draw. It's easy to visualize for introductory quantum mechanics, and it's now been in use for over 100 years in a periodic table. Excuse me. One key thing to know is the postulates. The Bohr-Rutherford diagram was given a postulate in 1922. Now that's 9 years after Ernest Rutherford got the postulates for his Rutherford diagram. Now, I guess just give you some bonus information. The Rutherford-Bohr diagram is a controversial name because a lot of people say that, it was Rutherford's idea first, but it was essentially Bohr who did all the work. There you are for my references. I used a handful of references. I consulted various reputable websites. I had IEpedia. I used University of Oregon here. See BBC, Encyclopedia Britannica, and Biodifferences is a science website. So I use lots of reliable sources, and thanks a lot for coming to the presentation. Have a nice day. Bye, everybody.